Hello and welcome to Crafty Lens Programming in Java. Yes, today we are doing a little project, and I called it Projectile Vomiting, but it's not like that, don't worry. We're going to look at how to find out the path of a projectile. So I've done this really bad drawing, and forgive me. So we can close that. We want to find out this information here. This is the path of a projectile. All right. Now we have two. Let's call it this one and this one. So this is your X. I'm very bad at freeform drawing. This is your Y. Oh. And X. Stupid me. Okay. Look at that. That's terrible, that, isn't it? So what we've got some information here. So we need to find out some different steps. So what I've done is I've written some. The goal is to show the X and Y position and time of a projectile whilst in motion, saying the different positions and time in a series of steps. So this is this. So we want to find out, say there's a baby here and he projectile vomits. So it's going to go, we want to find out where it is, how fast and the time it's taken to get to this, and boom, back here. So we have to use angles, and I'm not very good at angles, so I've been studying up. I kind of give you the physics behind it because my physics is horrible, which just inclines me to want to learn physics now. And so I might do a physics series, but I have to get a better maths thing, a drawing thing than this. So we want to do that. So I've written a little bit of pseudocode. So I want to give an introduction, okay? And we need to get three values from the user, namely velocity, angle, and the number of steps we want to show in the, Then you have to find the X and Y and time taken for each step. So this is the X and Y. So for example, let's just do this back down to here. Boom. And oh, terrible. So this is going to be 0, 0. So we want to find out the time taken to get to here and where it is. So see, that's 1 and 1. I don't know. And the time taken. And then for this step, this step, this step, this step, this step, and blah, blah, blah. That's the idea. This is the big idea. Okay. So we need some variables. And we need to get them from the user. So we're going to have to use that scanner thing. And we have to find the X and Y and time taken for each number of steps. So we've got a for loop. And then we'll have to print that out on a table. So this next bit is how I've had to get it, because you have to use, a lot of physics formulas. So this is what we need to find out. So we're going to just start by creating a class called projectile, and we're going to use some. Oh, there we go. Now we're going to create a method called projectile vomiting. Now I've done that wrong, haven't I? You've got to do it with, you've got friggin' convention. Vomiting. This is going to be the thingy that runs it, that we're going to call in our main method. So we're not going to write anything in there. So we're going to get another method called public with a small p, otherwise it doesn't work. Public void get user public voice get user input. Okay. So because of that, we need three variables. Those three variables at the beginning, we need our velocity and number of steps. Now, for speed, we would have to use a double of velocity. Okay, and a double for angle. But we just can use an int for number of steps because it's 1, 2, 3, 4 for that. So we've declared three variables. That's okay. So we're on form. What do we do now? So we need to get three different values. So we need a scanner object. Ooh. So we need a scanner object. Let's have a look. We can do it in this one. Get user input. We don't need a scanner input equals new scanner, and remember we have to put system dot in has to come into it, and we have to import it. So remember to import is Control Shift and 0, and look, oh, it's come up at the top and we stop getting the error. So we've got to say something, haven't we? System, let's do a sysout. Please, with a capital P, please enter the speed, the velocity, and it's going to be meters per second. Okay, so we'll do that, and then input equals velocity, sorry. Velocity equals input next double. Okay. Now another sysout. I love that shortcut. Very good. Any shortcut you can get, marvelous, wonderful things. We're going to do a string in here and put please enter the angle in degrees. Of course, the baby knows this all. Now here's a little thing we have to do. Angle. Because Java is a bit funny, it calculates something called in radians, which is another way of measuring, of dividing up a circle. So angle equals, we have to do this math, and we've got to put 2 degrees, and then we have to put input dot next double. So let's explain that. Because we're not getting degrees automatically, because Java is funny that way, which is strange. I don't know why. Maybe it's made for scientists. They use radians. I've never heard of a radian before, so I'm a bit of a thickie. But apparently you have to put this one to get the degrees. So that's all. If you know more about radians than me, please tell me, because I'm buggered if I know. Now please enter the number of steps you want to see. And I never put full stops. I don't know why. That's really thing. So this is the user input, and steps is equal to input next int, isn't it? next int, and that's it. Okay, and then apparently you have to input dot close just to get rid of that friggin' thing. So here we've got our first step, so we can put that there. That's our first step done, no problem. See, we didn't have to put anything because this is part. So what is our next step? Let's have a look. Right, so it's this step basically. So this is the table. Alright, we could give the introduction. We'll leave that to last, I think. Okay, so we print generate, we'll do it there, public void generate table, and this I think we'll need some parameters, but we'll see as we go along. Because we never know. So what we have to do is, let's look at our pseudocode. Save that and save that. Okay, so we have to find the x and y component of the velocity, because with so it's gonna be, we're gonna need obviously we're gonna need this, so we're gonna need two new thingies, two new I keep pressing the wrong buttons, two new things. So let's create that double x velocity. Let's put that x velocity equals, so we need to double velocity. Now, because we've got velocity here, we have to put the, we have to differentiate it between the two. So this, we have to use this velocity is the same as this one. Okay, and that's, is that right? Yeah. This velocity, why haven't you, or is it the other way around? No, it's like that. You have to see this velocity, this one. It should be blue. Why is it not blue? This, it's, there we go. This velocity, it is true, equals velocity. So we know we have to do that. So what we have to do equals velocity, the one we put in. Now we have to use a bit of working with angles, and I don't know this, so I just looked it up, and you have to get that times it by. Now the math class has a method called sine. It's the sine of the angle apparently, and we haven't got this, so we need double angle. We need to bring that into here. So this dot angle equals angle. Because what happens if we don't put this, when we're getting the user input, we're getting all these, we're putting values into these variables, and this is taking these variables and using them, you see. So we need to do this angle is the same as that one, so it's using these variables, not just any old other ones. Okay, so, and we have to put angle here. Okay, this is going better than I thought. Now we have a new one, double y velocity You think I would be able to spell city, yeah? Equals velocity times, now what is it? Let's use the cosine. So math dot, and we're going to look for a cosine. Do we see one here? Yes, and we can say angle. So that's how we're calculating the velocity, apparently. Now, this is all taken from a physics thing, so don't get me. So yes, we need a constant. So here we need a constant. We need to calculate for gravity. So remember, it's public static. So we have to calculate the acceleration. So we need a constant for gravity, which is just acceleration. So we're going to do public static final double and we have to put it in capital letters, acceleration. I think that's spelled right. I'm probably spelling that completely wrong. How do I spell it here? Acceleration. And that's equal to, now because we have to put the Earth's, which is, what is it, 9 point, I think that's it, 9.81. We have to put it in the negative because we're coming down, we're going down, you know, it's the real, it's going to be affected. It's not pushing up, it's pushing down. So we have to make it a negative. So we've got our final there, that's quite good. So we've used one of these already. Okay, and we've got the parameters. What else do we have to do? Alright, find total time taken. Alright, so we need a new thing called total time. Okay, and that's the formula. I don't know why, but it is. Don't ask me about physics, this is about programming. So double total time equals, now what was it, minus 2 times y velocity, which is that one, times y velocity, then we have to divide it by acceleration, or gravity divided by, and we should be, there we go, acceleration. So that's how we find the total time from the, because all you're given at the beginning is the velocity and the angle. So if you give it a crappy velocity and a small angle, it's not going to take too long. But the large, you know, the more velocity and the bigger the angle, the longer the time, I suppose. Okay, so what do we have to do next? Writing this code. This part took the longest. I'll tell you, just finding it out and putting it in there. Now we have to divide this because we need these time increments. Okay, so you want to find the total time it takes, and you want to knock it into little increments so we can see the steps. So which was what? Time increment. So double time increment equals what? Total time. So we need another parameter here, int steps, and we have to put this. I hope this is true, because I did before and it didn't seem to. I've used them before without this thing. This steps equals steps. So total time divided by steps. Okay, that's looking good so far. Can't complain. Now we have to calculate the x velocity. You have to calculate x, and you have to calculate x velocity, and the, what's this one? Oh, I remember now. Because x doesn't change that much, but the displacement, the y. Let's look at our little picture. You see the x, the y changes. Okay, this is basically it. You know, so that's what I understand. So this is what I understood. So we have to put an x increment. Because we have to use it down here in the thingy. So these two are going to be used in our for loop. So we have to do a new. Let's go double x increment. X increment equals what? What does it equal to? Time increment times x velocity. That's correct. Sorry I use all these shortcuts, but typing everything out is just a right bugger. Accelerate. I'm not sure I've spelled that wrong. I have as well. Oh. Acceleration. Change. You can change them on the. This is a good thing about this. If you make a mistake, you can just change it, because you hover over it with your thing and just change it to whatever it wants. So it's a real time saver. Okay. And what else do we need? Displacement. That looks like a very common thing. Now, so what we're going to do, we made a little util, crafty math. So we're going to get rid of a couple of stupid things. Okay. Oh, we've got gravity there as well. I wonder if we can use that. Ah. So let's get rid of this. Well, no. Let's equals crafty math dot gravity. And we don't have to change it. That's good. So we're using what we learned the other time. Now I want to use, we're going to use a public static. Now what do we have to do? Displacement. And we have to do a return method. Double displacement. So we're going to add a little method to our mathematical utilities class. Right, yeah, it's looking for a return. So what we're going to do is create a double displacement. And just create that for a second, and we can return it. Just get rid of these piston errors, because I know I have to initialize it. Yes. So displacement, and we might have to get some. Because look, we need acceleration. So I think we have to maybe put time in it and acceleration. Yes. And 1 second now, I'm just going to check something. Okay, so we need three things in this one. We need double velocity, double time. I'm just going to do this quickly. Double acceleration, I think it is. Okay, because if we look at the formula, it's V times T, okay, plus 1/2 or 0.5, not 0.5 times acceleration times time times time. So it's times A times T, no times. It's actually T squared, but you can write it like this. There is actually a thing, for example, in Java where it's called precedence. So it's always going to do this first and that first, and then add them all together. I think. And so that's our little displacement method. So we've got our crafty maths, and we've got it here. Okay. So we don't want that one. Keep changing that one. We have to go to our back here to see what we're doing now. So we're going to calculate x velocity. So we've done that, and we've done a little method for that outside of it. So now we're going to do the for loop. All right. And so for int, for parentheses, int I equals 0, semicolon, I is greater than steps, which we've got there, beautiful, I plus plus, not now, I plus plus. And this is our formula, which we've got to look here. So we need some variables. So double T, and we'll just initialize them to 0 if we can do that. Double X equals 0. Oh no, it's because the equals and the 0 is on the same thing. And the double Y. Nah, there we go. Now I hope they work inside, because I don't know if you have to put them outside or inside. Maybe we have to put them outside the loop or inside. I'm not too sure, so we'll have a look. We'll check it. So time plus time increment. That's so that right. And I'm going to show you a little shortcut. As if you see here, I've got time is equal to time plus time increment. So you're writing this thing twice. So Java has a little shortcut. So T equals, and you, instead of putting T again, you put plus equals time, what was it? Time increment. Yeah. So X is plus equal to X. So we can do that. That's no problem. It'll be X velocity, won't it? Plus equal to X velocity. Let's say. x increments, sorry. And y equals crafty math dot displacement. So we've got the velocity. Ugh. And how did we do that here? So I need time. Acceleration is going to be acceleration. Okay. And velocity, I think this is y velocity. Because we timing and total time. Because we're putting time is plus equal to timing increment here, so that's not too bad. And we have to print this out. Print line. So now we have to print out everything. Oh, Jesus Christ. So we're going to print out I, because that tells us, and we're going to have to do probably a thing before I. So that's the number of steps. So we want, we've got to put a plus here, remember. This is a plus. So we want x plus, we'll do a space. This is a bit funny, this one. Plus y plus space plus t. Okay. Is that how we're doing it? Print out x, y, and time. So that's what it should be printing out. I, x, y, and time. So I is the number of steps. So let's get user input. Let's generate table. And it's going to need velocity, angle, steps. Perfect. And we're going to make some adjustments to it, but at the moment, excuse me, it should be okay. Let's save that. Let's get our main parameters. Why was it's because I've get rid of them just to get rid of the error and stop doing that. Stupid errors. They all show up and you think, what's going on? And we need our main. So what have we called it? Projectile. Creating the object, giving it the variable, and now we're going to initialize it or create it basically. New projectile, and we're going to go proj, and what have we got? Projectile vomiting was our. So let's have a look. This is just a raw version, of course. Please don't take this as to be, but you have to check it once in a while. Please enter the velocity, meters per second. So let's say 30 meters. Are we here? 30. Angle in degrees. Let's say 45. And then I'm at 20. Whoa! That didn't take very long, did it? So, see the problem is here, this makes no sense whatsoever. So we have to put, you have to go back to our, well done. Well, I'll put 30 there. Projectile. So, we have to do something here. Sysouts. So we need to introduce, and I think we're going to change that to 1 because it's 0, it should be 0, 0, 0. And we're going to put what is it? Steps number, or we'll just put steps. And there's a good little thing, it's called a, I think if I'm doing it right, or is it another one? Nah. To tab it, we do T like that, and it moves it along. Plus, we'll see in a second. We want X and T plus is it Y, and we have to get that one again, T. I'll explain this T thing, don't worry, if I can. Plus time. I don't think we have to do it. Well, we'll do it anyway. Why not? I've forgotten the thing for it. There we go. T. Time. T time. So I think we have to do the same here, really. We have to do this thing. We'll just put it, can I put it here, you think? We'll try, who cares? And save, run it. Meters per second. Let's put a lot. No, let's put 50 meters per second. A big, and let's put a bigger angle. 90. No. Oh, just 10. Oh, now 90 was probably, so that's wrong. Why are we doing the steps is good. We've got a space, a tab, but we've got this because we've got huge numbers. That's why. Let's just run this again and do the little. Let's put 100. This is real. And we're going to put a 70-degree angle, and we put just 5 steps. So how can it be -1? This is what I don't understand. The time taken is -1 second. It's like boom, quick. Maybe the velocity is too much. 100 meters per second, but it's still, let's say 10 meters per second at a 70-degree angle and 10 steps. So I think we've got a problem here. But within a long time, so we're going to stop here and we're going to do problem solving in the next one, because we haven't got time to do it now. This is a long episode. So we'll see you in the next part of this, and hopefully it will be okay. You never know. See you soon, and have a good